So here's FRQ number 2 from the 2015 AP Stats exam. Situation that's presented is talking about a restaurant owner that's running a promotion. Customer's bill is going to be randomly selected to receive a discount when they check out. So they've got a program that's going to randomly determine whether or not the customer gets a discount on their bill. The program is intended to generate a discount with a probability of 0.2. So 20% of the bills should receive a discount in the long run. The owner is not convinced that that's actually happening. So he thinks there's an issue with the program and that the intended long-run proportion of 0.2 is actually not being attained. So the owner selects a random sample of bills and found that only 15% of them got the discount, builds a confidence interval for the long-run proportion of customers that receive a discount, and the confidence interval is shown right here. Says all conditions for inference were met, so we don't have to run through any of the normal things that we would need to do in a problem where we're building the interval. We just need to do some interpretation here. So in part A, it's saying, all right, here's your interval, same one that was presented back here. Does the confidence interval provide convincing statistical evidence that the program is not working as intended? Justify your answer. So you've likely talked about the relationship between a significance test and a confidence interval. We don't even know what the confidence level is here, but we don't really need to know it. 0.2, if you compute this interval, right, go up by 0.06 from 0.15, you get to an upper endpoint of 0.21. 0.2 is included within this interval. That means it's a plausible value for the long-run proportion of customers that randomly receive a discount, so we do not have evidence suggesting the program is not working as intended. Always with your wording, try to be non-deterministic, right? This word suggesting here is saying that it's possible that the program is not working as intended, but we don't have evidence suggesting that that's the case. Now, the second part of part A is saying, does the confidence interval provide convincing statistical evidence that the program generates the discount with a probability of 0.2? Justify your answer. And if you think about it, you might initially think this is really something that we've already answered in the first part of this, but this is more after what an interval does and what it does not do. The interval gives a range of plausible values where our long-run proportion is likely to sit, 0.09 to 0.21. And yeah, 0.2 is included in that interval, but the interval itself can never be used to prove that you do have a specific population proportion. So that's basically what I've said here. I guess the only other thing to say about this screen, you'll notice everything is in context. I've referred to the randomly selected customers receiving a discount multiple times in this, and that's something you're always going to want to try to do in your verbal responses to stats FRQs. We go with a second random sample of bills, and it was 4 times the original sample size. In the second sample, we also had 15% of bills that received the discount. The reason why I said also is because if you think about this original interval, this is the point estimate or the sample proportion from the original interval. I guess they said that back here as well. But we have the same proportion of bills that received a discount in the new sample as the original sample. We're asked to determine the value of the margin of error based on the second sample of bills that would be used to compute an interval for P with the same confidence level as the original interval. So it is a little bit weird that they never provided us with that confidence level. So as I was reasoning this out, I just tried to say, okay, how was that original margin of error, that amount that I was moving up and down from my point estimate by, how was that computed? And that's going to be computed by taking our critical value, which for proportions, we're always dealing with z's, never a t-distribution for proportions. So I'm going to have some z star value, which I technically can't find because that would be associated with the confidence level, and that's never mentioned to us here. All we know is we know that the new confidence level is the same as the original. And then if you think about how you would find the standard error for your for your sampling distribution for a sample proportion, you're going to take the sample proportion times its complement, divide by the sample size, and toss that all under a root. Now this would be how the original margin of error got computed. So I thought, all right, let me see how this new margin of error is going to get computed. I'm going to use the same Z star value because I'm still using the same confidence level. I have the same sample proportion, so I still have the same numerator. But what I'm doing is I'm quadrupling the original sample size, right? 4 times the original sample size. So this denominator is where the only change actually happens. It's going to be 4 times n rather than just n. Well, this 4 is under a root, so if I wanted to try to simplify this expression a little bit, I could do the square root of 4, turn that into a 2. Now notice it does stay in the denominator, right? The 4 is in the denominator, so when I take the root of it, it's got to stay in the denominator. I can bring that 1/2 out in front of this calculation that you see here, and what you'll notice is this original margin of error is now showing up right here. So how does the new margin of error change from the original? Well, it's going to be half of the original. So if I take that original margin of error of 0.06 and I multiply it by 1/2, divide it by 2, I get my new margin of error of 0.03. Final part of this is saying, now that you've got this margin of error from part B for the second sample, what do you conclude about whether the program is working as intended? Justify your answer. Well, if my new margin of error is 0.03 and my new proportion from the sample is still 0.15, my new interval is only going to move up 0.03 from 0.15 and down 0.03 from 0.15. So that gives me a new interval of 0.12 to 0.18. This interval does not include 0.2. Based on increasing the sample size, and keep in mind when you increase sample size when you're dealing with sampling distributions, you're going to reduce variability. All right, standard deviation is going to get smaller, standard error is going to get smaller. So based on the fact that 0.2 is not included in this new interval with the increased sample size, we do have evidence from this sample that suggests the true long-run proportion of customers that are randomly selected to receive a discount is not 0.2.